Hi guys, Mr. Hill here with your science lesson for today. So we're going to carry on looking at materials and their properties. Today we're going to be looking at what a thermal insulator is. So by the end of today's lesson, you're going to be able to understand what a thermal insulator is, and also you'll be able to do your own little investigation to work out what would make a good thermal insulator. So some things to consider before we get started. Hopefully by the end of today's session, you will know what conduct and insulate mean. You might already know what these mean, but you might not know quite what they mean in this context. So that's what we're going to aim for today. We're going to make predictions using our existing knowledge, and we're going to investigate which materials are efficient thermal insulators. So let's get started. The first thing we're going to need to think about is know what conduct and insulate mean. To conduct means to allow heat or electricity to travel through the material. We're not talking about a conductor of an orchestra who you quite often see waving their hand with a little stick. That's not that sort of conductor we're talking about today. So it allows heat or electricity to travel through it. For example, if you heat one end of a metal bar, the heat's conducted along the metal and you will burn your hand. So what happens is you'll end up with, like in our image on the screen there, you'll have the heat source, that's the candle, will warm up one end and that heat will travel along, and all of a sudden you'll think, oh, that's really hot, and you'll burn yourself. So today we will be looking at heat, but also materials that conduct electricity. So we'll be talking about both sorts of conductivity. To insulate, to not allow heat or electricity to travel through the material. For example, as I'm sure you've done the last few days when we've had the snow and the cold, you've had a big, warm, thick winter coat on. It insulates you by keeping your body heat trapped inside and not letting it out. Today, that's what we're going to be focusing on, heat and keeping heat in. But as we've said, other materials can also be electrical insulators. So our homes are insulated to help us save energy and money. We put layers of special insulating material in the roof space designed to trap the heat in the house. So think of it as a coat for your house. So we've got this fiberglass insulation, which we lay down, we fill all the gaps with, and it just keeps that heat in. So it works like the filling in your coat. It goes in the walls, it goes in the ceilings, it goes in the roof, it goes everywhere there's a gap in the house, and it fills up that space. So here it's being installed into a wall. By using a special thermal imaging camera, you can see how much heat, so it's the energy, is escaping from a house. So if you look at the house on the left, it's very blue and green. There's not a lot of heat coming out of it. If you look at the house on the right, the windows there are glowing red. That's the heat coming out of the house. So those are poorly insulated windows, which means that house will be colder, which means the heat will need to be kept on for longer to keep the house warm, which ultimately ends up costing a lot of money. And at the moment, there's a big push on looking after the environment and keeping everything safe and helping slow down global warming. By making sure a house is properly insulated, that will help this take place. So as I said, the house on the left is well insulated. We're showing lots of blues and greens, very little heat escaping. The house on the right is not insulated well. As you can see, there's lots of reds and yellows. And if you look on the right of your image, you can see -1 where there's blues and greens at the bottom and 13 up at the top where there's reds. So you can see quite how much heat is escaping from that house on the right. So some materials are designed to allow heat to travel through them easily. These are called conductors. Some materials don't allow heat to travel through them easily. These are insulators. So we've talked about how insulation can be used for a coat to keep you warm, and insulation in a house to keep the house warm and keep everything nice and cozy and warm. So when we have cold winters like we're having at the moment, it's nice and warm and it's cozy and everyone wants to be indoors. So these are both important properties, but they're very important in different objects. So depending on what your object is designed to do. So I know that a lot of you are helping out at home, and some of you might even be helping out in the kitchen. So well done, everyone. Let's think about a pan. So it can be a frying pan, it can be a pan for boiling potatoes in, cooking rice in, it can be a big pan or it can be a little pan. Just want you to think of a pan you've got in your house. So our chef here is holding up a frying pan. Let's have a look through it. You need the main part of the pan to be a conductor. So the heat from the hob reaches the food. Now you might have an induction hob, an electric hob, a gas hob. There's lots of different types of hob, but they all generate heat, and that heat needs to be transferred into the pan in order to cook the food. It's no good trying to cook rice in a cold pan. You'll just end up with cold, soggy rice, and it won't taste very nice. So the main part, so that part the arrow is pointing at, is made from a conductive material. So manufacturers often use metal for this part, because it's an excellent conductor of heat, and it keeps, some of them keep the heat as well. But if the heat traveled all the way along the handle, we'd end up burning our hands. So if we went to take our pan off the hob to go and strain the water off our pasta, for example, you'd end up burning your hand trying to move it, because the heat from the pan would have traveled from the metal of the pan through the metal of the handle. And as we know, metal's a good conductor of heat. You'd end up burning yourself. So you need something that's insulated on this. And the material for the handle needs to be an insulator. So the handle, where our chef here is holding it, so there's often used strong plastics for this part. So these are plastics that are stable when they're hot. So it's no good having a plastic that melts when it gets hot, because you end up with hot melted plastic all over your hands while you're cooking, which is, we definitely don't want that to happen. So what types of materials make good thermal insulators? What materials keep the heat in? We've talked about our coats. We've touched on plastics because they're good for stopping us burning ourselves. We've talked about insulation in houses, and it's made of various different materials. So today, you're going to do an investigation into the materials that kitchen containers are made out of. This is a heat experiment. We're going to be using hot water. So please, please, and I'm going to say it one more time, please, using the rule of 3 there that we've learnt in our writing this week, last week even, it's really important you have an adult helping you set this up and someone supervising you, just in case something goes wrong. We'd hate for any one of you to get hurt. So I'm going to say it again. Make sure you've got an adult with you to do this experiment. So your task, going to find a selection of containers of different materials. So for example, a coffee mug, a glass, a pan, a Tupperware pot. So all of these are good ideas for things you could try out. Second thing you're going to do, you're going to carefully pour hot water into each container. So it's about half full. So think about the containers you're using. It's no good trying to fill a bucket with hot water when you're comparing it with a mug. So try and keep things to a fairly similar size. So it's not a completely fair test because we're not going to get an exact same size for everything, but it's going to help give us some information that we can use. Make a prediction. Which container will keep the water warm for longest? So think about what your material is. Think about what we've talked about, how some materials are really good at conducting heat. Some materials are better at keeping the heat in. And then wait. Set a timer for 10 minutes. Go back and carefully feel the outside of the containers. Which one feels hottest? Now, this is not really a fair test still, because you know, it might feel hotter to someone, one might feel hotter to somebody else than it does to you. What you could do, if you've got a thermometer, you could test the heat of the water in each one. And if you have got a thermometer, you could maybe do a check every 5 minutes to see which one is losing heat the quickest. That will tell you how quickly they're using their heat. And if you do that, What you really do need to do as well is test the heat of the water as soon as you put it into the container. And then you can see that the water started off at, for example, 80 degrees. After 5 minutes, it had gone down to 75. After 10 minutes, it had gone down to 60. And then you can start getting some really useful information. If you don't have a thermometer, don't worry, just use the outside, carefully feel the outside of the containers. What I would suggest you do is use the back of your hand rather than the front, because if it's really hot and you touch it with the back of your hand, you can move your hand away really easily. If you grab something like that with your hand, you might burn the palm of your hand, and we really don't want that to happen. So remember, we're working with boiling water here. So it's potentially dangerous. It will burn if you get it on your skin, and we really don't want that to happen. So what you're going to do, you're going to rank the materials from the best insulator, so which one stayed the hottest, to the worst insulator, so which one felt the coldest after your time. Create a table of your results. So something like this. So you will have your container, so what it was. You'll have a column for what material it was made out of, and you'll have where it finished in the rank. So whether it was first, second, third, fourth, fifth, however many different containers you found. Good luck, everybody. I hope you have fun doing these experiments. As I said before, please be careful. Make sure you've got an adult nearby, especially as you're using boiling water, and make sure that they're there to help you if you need it, and make sure that you're not going to hurt yourselves. I look forward to seeing your work on Tapestry. Take care, stay safe, and I'll see you all again very soon.